All right, so we're going to start with squaring both sides. When I square the left-hand side, my radical cancels out with the square, and we're just left with our 2x minus 9. And what's on the right-hand side when we square this side? 1/9. 1 squared over 3 squared. Then what are we going to do? Add 9. So we're going to get that 2x equals what?
82 over 9.
82 over 9. Common denominator. 9 would be the same thing as 81/9. Plus 1/9 gives us 82/9. So then what?
Divide by 2.
Divide by 2. Yep. So multiply by 1/2. So if we struggle with the dividing of the fractions, you can always think of it as multiplying by the reciprocal. Divide by 2 is the same thing as times 1/2. So we get what? 82/18. And then you gotta simplify. It's actually easier to simplify it up here. Exactly, because 82 divides by 2. We can think of 82 as 41 times 2.
Oh.
And then my 2 and my 2 cancel out, and we get our 41/9. Okay, so sometimes it's easier to simplify a step above. I mean, if we had a calculator, it wouldn't be a problem. Yes, Meneer? No such thing. You could, but you'd still wind up having to simplify very simply. So you get 18x equals 82. And you still want to get x all by itself. But if that's the way your brain want to go through it, absolutely fine, and it's 100% valid already. Okay. So since we're dealing with radicals and we have squared both sides, we need to double check and make sure that our answer is valid and not extraneous. The things that's going to make it extraneous is if we have a negative under the radical, so an imaginary, set equal to a real number. Because a real number and an imaginary are not equal. So what we really care about is, does my x value give me a negative under my radical? So will 41/9 in place of my x give us a negative under the radical or give us a positive?
Negative. Positive. Times 2.
I'm pretty sure that's a positive. So that's way too many.
Because
Oh, yeah.
41/9, and then we multiply by 2, would be back to our 82/9. 82/9 minus 9. We'd be left with our 1/9, which is positive. So we're fine. But it's going to be really important that we check every one of our solutions to make sure we don't wind up with extraneous answers. When we're solving our square roots and we have squared both sides, we can wind up with extraneous solutions. So it's important to check.
So we check if the x is, if it's extraneous or imaginary, if the x is like in a radical or in a denominator.
If we have a negative under a radical, so an what would be imaginary, set equal to a real number, so a positive. I could have an imaginary next to an imaginary. I could have a real next to a real. Totally fine. Just imaginaries and reals are not the same. So let's look at our right-hand one. What's going to happen here? Add 2 to both sides. I want my square root, my radical, isolated before we try and solve anything. I do not want to square with a addition or subtraction on one side unless I absolutely have to. So my square root of 2x squared plus 1 is going to be equal to 2. So get your square root by itself first, and now we can square it to get rid of my square root. So I'm going to square this piece and this piece. My square root and my square cancel out. So we're left with our 2x squared plus 1 equals 4. Then what are we going to do? Subtract 1. I think you're like 3 steps ahead of me. That's okay. That's okay. 2x squared equals 3. So what does x squared equal? 3 over 2. So what does x equal?
Plus or minus
Square root of 3 over 2. So we've got plus or minus. So we're going to think through both answers. My x term is squared. So is that going to be positive or negative? Even if we wind up with negative something.
Wait, what?
If we think about, so we're looking at our check now. No matter what we substitute in for x, since that piece is squared, and that highlighter does not show up at all. Better. Okay. Since that piece is squared, no matter whether we have positive or negative terms going in for x, it's going to be positive, right?
Mm-hmm.
So 2 times a positive number, positive or negative? Positive. 2 times a positive is going to be positive. Plus 1, positive or negative? Positive. So no matter what, what's under my radical is going to be positive. So this is going to be a real answer. Like, this is going to be fine. We're going to have 2 solutions, and that's okay. Do I have a radical in my denominator in my solution? Yeah. So we got to fix that. Sorry. All right. So I'm going to give us a little more space here. We've got to fix it, get the radical out of our denominator. But when we have a radical in the denominator, sometimes it's easier to check it first. So if it's extraneous, we don't have to rationalize it. But since we have valid answers, we're going to do it. We've got our square root of 3 over square root of 2. So what are we going to multiply by to get this to rationalize? Square root of 2. So x equals plus or minus square root of 6 over 2.
And so what are they asking for in this equation? Like, why don't we just stop at the plus or minus square root of 3 over 2?
That would be a solution. It's just got a radical in its denominator, which we're not supposed to leave them there because it's not good grammar. So in the instructions of every single quiz or test you take in this class, it has in the instructions all your answers must be rationalized. That is copy and pasted from the IU instructions for the final. That's why we always have the same set of instructions at the top. Yes, Megan. That's okay. No such thing. Because there's addition under the radical. So if it was just, let's say, square root of 4x squared, absolutely you should put it as 2x. Totally fine. But since it's got that addition under there, it'd be like having, if it was just numbers, 4 plus 1 under the radical. Well, under the radical, order of operations says I have to add those together, so it's square root of 5, not 2 square root of 1. Okay? So we have to deal with the radical before I can deal with the sum inside. Okay. Questions on these two? Because that was our valid answer. I'm just highlighting it so we have it. Okay. Let's do more. All right, So now we have square root of 7 minus x equals x minus 5.
Wait, since you're in the equation, do you have to like,
Give me more, give me more.
wait, cause it's in a
Uh-huh.
equation, you can
Uh-huh.
do the same things, but you'll just leave them on their sides, like.
Uh-huh.
So it'll-
Keep going. What are we going to do to the left side?
Great, just balance.
We're going to square it. What are we going to do to the right side? Square it. So I'm going to square this side. That's going to cancel out my radical. And I need to square this side. Not the individual terms. The whole side.
So x minus 5.
X minus 5 quantity squared. So my left-hand side, my radical cancels out, and we're just left with our 7 minus x. What's my right-hand side going to be?
X squared plus 20. Oh,
X squared minus 10x plus 25. What do we need to do to be able to solve this? Set it equal to 0. So we're going to add x and subtract 7. So to get this equal to 0, we're going to have x squared minus 9x plus 18. Now we need to solve this guy. You can solve in any way your little heart desires. You can quadratic formula, you can complete the square, you can factor. However we wish. This one does factor. And our a value is 1, so we don't even have to do any like super duper hard factoring. Like this is our easy peasy. All we need is our two numbers. So what is our factored form going to be? X minus 3 and x minus 6.
Or solve it, right? So
We're solving, so we're not done here. For those of us that got confused, because I heard a what come up. So we got 18 over negative 9. For those of us that use the box, our pair of numbers that multiplies to make 18 and adds to make negative 9. We got our negative 3 and our negative 6. Does that help with the what? Because I heard a what. Okay. So what are our solutions?
6 and 3.
Yep, x equals 3 and x equals 6.
is that it?
We gotta check it.
Oh.
Yeah. Yeah.
Wait, so if it equals the same thing on the east side, then it's good, and if it doesn't, it's bad.
Really what we care about is, are we getting negatives in places we shouldn't?
Oh, it's too
So that's what we're checking for the check. Like, we don't need to fully plug in. If you want to, fully substitute in, totally fine. But all I really care about is, am I getting negatives in weird places? So I wind up with, so with the 6, we're going to have a positive here and a positive here. No worries, we'll be good there.
But
With the 3, I get a 4 here and a negative 2. Is it okay for my square root to equal a negative? Let's get, so let's write it. Let's write it.
maybe it's-
Because,
Oh, it's plus and minus.
yeah, because 7 minus 3, so we're having square root of 4 equals negative 2. Is that okay?
Yeah.
Why is it okay?
What's
Yes,
negative 2
because-
squared?
I know it's plus minus 2, but,
Yeah, so plus or minus.
oh, it's like it's equal, okay.
Yes. So it is okay for a square root to equal a negative.
So
What we can't have is square root of negative 4 equals 2.
So the square root.
Because square root of a negative number is an imaginary. So I can't have a negative that equal, like I can't have an imaginary that equals a real.
Right.
Right. Okay? So both of these are valid. But it's important to check. And that's why I went through it instead of just going, yeah, no, they're fine. Just move on with our lives. Okay. Questions on this one? Deep breath. These are about to get real gross. Deep breath. Deep breath. I've got square root of 2, square root of x plus 1. So a double square root here equals square root of 3x minus 5.
Is this like an actual problem where you just find it going?
No, it's an actual thing.
And do you think we're gonna just do it to
this?
the fourth tower?
It's entirely possible. Just do it twice.
Could you do it to the fourth tower and then take out both?
The logistics of that's going to be obnoxious. I think you can, but I've never done it that way. But I think you could.
I would do math any day over.
All right.
Yes.
One step at a time. Start from our outside and work your way in.
Okay.
So our outsidiest piece. What are we going to do to get rid of our outsidiest piece? Square it. Let's get rid of something. Oh my gosh, because this is gross.
What do you have squared twice?
Square. We will have to eventually, yes. I'm going to square both sides. So this first go round, it knocks out this outside square root, and it knocks out this square root. We like that. Makes this way less gross. So I have 2 square root of x plus 1 equals 3x minus 5. Okay, that's less gross already. And I heard several people say divide. You absolutely can divide. It's going to give you fractions on the right, which we are then going to square. We can square the left-hand side where it is and have way less fractions to deal with. Okay?
We can do it in that order.
We can absolutely do it like that.
But when you square it, you also have to square the 2.
Mm-hmm. Because we need to square this whole side. But it's a product. It's like having 2x or 2y, 2b. I just got to square both pieces. It's a product. The right-hand side, again, we have to square the whole side. If you are a pro with fractions, you can absolutely divide and then square, totally fine. But that is honestly way harder and super gross. So, I was like, you can. And if you get through it and you get the same answer as me, you were good to go. It's gross. All right, so when I square my left-hand side, what do we get? 4 times the set of x plus 1, right? The quantity x plus 1. So 4 times parentheses x plus 1. That's like a tricky part on that step. It's 2 times something squared, so it would be 4x squared if it was just an x. So the quantity has to be there. The right-hand side, what are we going to get when we square 3x minus 5? Mm-hmm. Minus 30x plus 25. We got this. We got this. It's like the minus 15, we combine them together. Questions on that step? What should we do next? Distribute the 4. That's why I wanted to do one like this, because sometimes our instinct is too much. So this is going to give us 4x plus 4 equals that hot mess of a friend.
Are we still setting the equals zero? Do we not come subtract?
If you want to do it completing the square style, you absolutely can. It's going to be a lot though, because we're going to wind up with some weird fractions. So I've got an x squared. We are asked to solve to get to an x equals, which means we should probably set it equal to 0. So we're going to subtract our 4x, and we're going to subtract a 4 from both sides. So we have our 0 equals 9x squared minus 34x plus 21. And ew. It is disgusting. It is super disgusting. But honestly, these ones are nearly impossible to write with not ugly numbers. Because now we need to solve this thing. It does factor. Because it's going to multiply to make 189 and add to make that negative 34. So our factoring, I'm going to give you guys the numbers because these are super gross and it will just take a ton of time if we just sit here waiting for it. So, okay, so what we do if we're stuck on this part, make a list of factors of 189. So it divides by 1 and 189. It won't divide by 2 because it's not even. It will divide by 3. 62. It won't divide by 4. It won't divide by 5. It'll divide by 6, I think. Yeah. And it will also divide by 7.
6 is 34. 6 is 34?
Yeah, 6 is 34, and 7 is 27. 7 times 27 gives us 189, and 7 plus 27 gives us negative 34. So if you get stuck on that part, this is how you approach it. Make a list of things that multiply to our product of A and C. So negative 7 and negative 27 are our two pieces here. That's how our negative 34 splits. So you can factor by grouping, you can box it, you can do whatever it is you need to factor this. So I'll do it by grouping right here. Our 9x squared minus 7x plus our negative 27x plus 21. I squished it in my stuff. Whatever method you want for your factoring here. So what is our factored form? (9x minus 7 and x minus 3). So what are our solutions? X equals 7/9 and x equals 3. We're not done yet though, because what do we need to do? Check and see if we get like a real equals an imaginary, because that gives us a problem.
I think 7/9 would be negative because it's lower. If you substitute on that.
Mm-hmm. Yeah, if I substitute 7/9 in on this side, we're going to get a negative under the radical. If I substitute 7/9 into this piece, are we going to have a negative or a positive? Yeah, because 7/9 plus 1, that's positive. I don't care what it is, but it is positive, right? Mm-hmm. So I have a positive under the radical, which is real, set equal to a negative under the radical, which is imaginary. So with 7/9, I get a real equals an imaginary, which means this one is not valid. It is extraneous. So this one is not valid. It's extraneous. Oh my gosh, they made us do all that extra work. They are so extra. All we need to do is see, is it going to be positive or negative under the radical? I don't care exactly what it is. So check our 3. Is our 3 valid or is our 3 extraneous? Valid. The 3 is valid. So that one's good. But our 7/9 is extraneous. Okay. Questions on this one? That was not the last one. So we're going to do another big deep breath. Big deep breath.
I can't do this.
We can do it. I promise we can do it. I promise we can do it. But there is one like this on the homework. Number 30 is just like this.
Why? Why'd you put that on there?
I didn't take it. But there was a final that had one on this. Not recently, but there was a final that had one like it on there. It's not the same professor, because the professor changes like every 2 years, but there was a final like 4 years ago that has one like it on it.
Can we just square everything?
Square everything. But be careful because we're squaring the side. I need to square the left side and square the right side.
So they're all together?
Wait, what? That's actually boring.
Square, it's gonna be gross.
Wait, what?
We have to square the side to get rid of this radical here.
Can't we just like do it without the minus sign? Like it doesn't really do anything, does it?
It does. It makes a difference.
Ew, what?
I know. So this one's gross. We're gonna go through the whole thing. I promise. So I'm gonna write it out as a product instead of as a square so we can see what the heck is happening. So I'm gonna write this as our square root of 7 minus 2x minus square root 5 plus x times square root of 7 minus 2x.
Wait.
Oh.
That's what I mean by square the side. The whole side. My right-hand side is less gross. My right-hand side, my radical canceled out. And we just have 4 plus 3x.
Why does it No, like why doesn't it just cancel out 1?
What is a Precal?
Well, we technically haven't actually done anything yet. I just wrote it twice. We haven't done any squaring yet, because it will make some things disappear.
Yeah, some, not all.
We'll get there. We'll get there. All right. I know. These are gross. That's why I wanted to do one, because there's one like it on the homework. All right. First term times the first term. So that's square root of 7 minus 2x times square root of 7 minus 2x. That's not bad. That's 7 minus 2x squared. So the radicals cancel out. 7 minus 2x. That bit's okay.
Oh, okay.
That's, think of it as x minus y quantity squared.
Oh,
We would have
okay.
x squared
Okay.
minus our 2 center terms plus our b squared at the end.
The square root of 2 was multiplied by the square root of 2.
So then I'm going to take my first term times my second term. We're going to have minus square root. When I am multiplying two radicals, what can I do with the pieces under the radical? Multiply them together, right? Like if it was square root of 2 times square root of 3, we did square root of 6. This is 2 times 3. So this is the square root of, I was like, I'm just going to leave it as factored form right now, just to deal with it later. My x plus 5 times 7 minus 2x. Just leaving it there for now. I know, this is super gross. That's why I wanted to do one with you instead of leaving you guys on your own to look at it and panic and then not do it. Shock, right? Oh no, I totally know. We would totally do this on our own and never give up on it. All right, same thing with our second term. I'm going to take my first term times my last term. So we have another set of minus square root of x plus 5 or 5 plus x. I switched the order here. Times our 7 minus 2x. That is 7 minus 2x. And the green one is 7 minus 2x. It is this piece. Yes, plus 5 plus x. Because we now have our last times the last to get plus 5 plus x. Because our 5 plus x was times itself. Our 4 plus 3x is just hanging out. Okay. So we've done a big distribution. Questions on any of those pieces aside from O5y? Because that's usually the question is why? Because college. Sorry. All right. We have some simplifying we can do here. Because this thing is exactly the same as this thing. I have minus one of these, minus one of those. So we really have two of those. We also have some numbers, and I have some x's. So let's simplify that whole left side. I've got a 7 plus 5. 12. I have minus 2x plus x, which gives me minus x. And then we have a green one and a blue one, but they're exactly the same. I have 2 of the radical grossness. And I don't know why I switched my x and my 5. I'm going to switch them back so that they match the original equation. Our 5 plus x and our 7 minus 2x. And this is all equal to 4 plus 3x. Okay, so it's been a mess, but it's getting less messy. It's getting tidier. Because what can I do now trying to get that radical all by itself? Ooh, don't square it here.
Take the, subtract off the things.
Get the things away. Get all these guys to leave.
And we can't touch that -2 yet, right? We're just focused.
Let's deal with our adding and subtracting first, and then we can see what we can do with that -2. I'm going to do that in a couple steps. So I'm going to start with subtracting 12 from both sides. And we're going to add x to both sides. So we have our -2 square root of a hot mess. Yeah, and you can do it as either one, as 4x minus 8 or as -8 plus 4x, means the exact same thing. Now what can we do with that -2? Divide both sides. So we have 5 plus x and 7 minus 2x equals minus 2x plus 4, or 4 minus 2x. Nope, we gotta have x equals. So what do we need to do? Square it. Square both sides. My left-hand side, my radical, and my square cancel out. So all we'll need to do is do that multiplication right there. Now we're going to do that. So my left-hand side, when we multiply this out, and you can either get this into standard form or you can leave it in the way it comes when you multiply it out, we should wind up with 35. There's my 5 times 7. minus 10x plus 7x. So minus 3x minus 2x squared. And my right-hand side, we're going to multiply that out as well. My 4 times 4 gives me my 16. Minus 8x is minus 16x, bless you, plus 4x squared. We're getting there. I promise. I just put them in the order they would be if we multiplied this out right here. I did not put them back in standard form. If you put them in standard form, that's totally fine. I agree, this makes my brain itch, but it's the way that we tend to get it to come out. We're going to fix it in this next step for those of us that this is bothering. Okay. I see x squareds, and we're trying to get a solution. What do we need to do? Set it equal to 0. So I do recommend moving whatever our smaller x squared is because it gives us less negatives. We would like to really not have a negative a value because that makes our factoring so much grosser. So I'm going to move all the stuff on the left over to the right. So I'm going to add my 2x squared, I'm going to add my 3x, and subtract my 35. So we have 0 equals our 6x squared. I'm going to put this back into the proper order now. Minus 13x minus 19. And we are in another solve as your heart desires. You can complete the square, keep a quadratic formula. This will factor. We don't have a ton of time, so I'm going to give you what we would need to factor. Multiplying it together, we would wind up with 189. Nope, no, that's the last one. Negative 114. Sorry, I switched the order because I thought this one was harder, so I put this one last. Negative 114 over negative 13 would be our pair of numbers, multiplies a times c, b on the bottom, and it's going to be 6 and 19. Positive 6, negative 19. We could make our list of factors just like we did on the last one, 114. 1 and 114, 2 and 57, 3 and 38, 6 and 19. To find our pair of numbers that have a difference of 13. So putting this into our factored form, 6x squared minus 19x plus 6x minus 19. What's our factored form? X plus 1. 6x minus 19.
Oh, yeah, whatever.
So our solutions are x equals negative 1 and x equals 19 sixths. Super gross.
We have to check.
Okay.
Make sure there's no radicals under the desk or under the or negatives under the radicals. I was like, negative 1 times negative 2, that'll be positive. So 7 plus positive number, positive.
Okay, so
5 minus. Even she decides we're done. All right. So negative 1 under there would be positive. Negative 1 under there would be positive. So the negative 1 for sure valid. 19 sixths.
That'd be about 3.
Mm-hmm.
Okay, so
It's fine. It works. If you go through and check it, even our 19 sixths, our 7 minus the 19 sixths times 2 will work.
what about 4 plus 3x?
Plus. Positive.
Yeah. Okay.
Yes. So when there's addition under there, if you've got a positive solution, 4 plus 3 times anything positive is going to be positive. 5 plus anything positive is going to be positive. Okay? And as long as our fraction is less than, 3 halves, that will be positive. Okay? So, we did not quite get all the way to the end of 2.5. So, I'm pushing 2.5 back until Friday.
Wait, we already had the homework. Like,
2.4.
2.4 is due today. When did we have 2.5 announced?
2.5 is this one. This is 2.5. We're in 2.5. When we started with the absolute values was 2.5.
I didn't start it.
That's okay. We're pushing it back. You're fine. Okay? So I'll put the numbers up here. 2.5 is not due Thursday. It's
So
due.
many of them too.
Most of them are very short. Very, very short. Like, think of the absolute values that we did. Like the little things. Most of them are short. 30 is very much like the one we just did. Sorry.
Are 40 and 52 at least not like that?
They're how we're gonna start tomorrow. It's more like the U, like when we did that U substitution thingy. That we're gonna start tomorrow with those and practice those, but that's the end of 2.5. What's up? Yes.